Better? Yeah. All right, securely automating infrastructure in the cloud, which should be close to a lot of your hearts, I think, as we start moving to more of a cloud-oriented environment with AWS, Azure, if you're a little bit longer in the field, Rackspace Cloud, Google Compute Engine, and even some of the on-premises offerings like OpenStack and vSphere or vCloud. So I've been doing this for, I guess, just under 25 years at this point. I started my career as a developer, spent 15 years doing that almost, and I've spent the last 10 years doing systems and security, architecture, and platform design. My expectations for you guys to walk away with this saying, I already knew that, and I feel like most of you already do. I've heard today a lot about the struggle from the security side of getting people involved from the development standpoint or the operations standpoint. And I've heard a lot from the developers about how hard it is to make security work in your pipelines. This is somewhat about how we have made that happen where I'm working now at ICF Olson. And I think that it's sort of a blueprint for how you can work with your operations teams in order to get that done. So this is not so much a how-to guide as a how we did it guide. And one of the important things that we want is for it to be push button for everybody, even ourselves. We don't want to keep doing the same thing over and over and over again. Nobody does. It becomes boring, it becomes tedious, and you stop paying attention to what you're doing. So from the security side of things, everything revolves around the idea of minimum necessary access and do it securely or don't do it at all. I haven't heard a whole lot about minimum necessary access from the private side of things or the civilian side of things. It seems to be more of a government-oriented idea. But the fact is that from an operational standpoint, you really don't want developers touching your production systems. It's something that every DevOps engineer, every operations person, every sysadmin says. It's just, you can't track necessarily what people are doing. So, but on the opposite side of things, as a developer, you need to have that access. You need to get your code out, you need to make sure everything's running smoothly, you need to be able to have visibility into things. So, how did we start going after this? We needed to understand our security space. So we needed to know what we owned, what our partners owned, and importantly for my team, we run managed services for a number of different clients. So we're effectively an extension of their IT department or replacing their IT department, which means we have a lot of partnerships with other things that we might not necessarily work with. We tie directly into a lot of marketing departments, and we tie directly into a lot of other communications vessels that normal IT departments don't necessarily work with. We needed to know what they owned, but we also needed to know what our testing and analysis capabilities were. We also had to ask, what don't we know? And that's a hard question to wrap your brain around. If you actually start diving into that, the I don't know what I don't know circular conundrum becomes a real problem. So we started by mapping out our common infrastructures, the ones that were common amongst our clients, the ones that were common internally, how it was deployed, and what it touched externally. We also needed to know what tools we were using, how we were using them, and who could help us. So we needed to know who our executive allies, who our development allies, and who the security teams were inside of our own organization. So we found out what we built. It was this little thing. It was a dumpster fire. You guys over here on this side of the pond tend to talk about tire fires. That's great. We have dumpsters. This one was what we got. We could still toss trash into it, and it was still doing its job, but it wasn't really helpful. So what we needed an auditable, repeatable process that was integrated as fully as possible across the environment. So we needed to have it work from the ground up, make sure that all of our infrastructure was laid out the same way, make sure that once the infrastructure was up, it was monitored properly, make sure that we were logging all of our alerts, making sure that we had insight into that. And then once the infrastructure was in place, making sure the build pipelines were fully integrated and tied into that infrastructure so that our developers had full access where they needed it and wouldn't come back to us saying, hey, I need root access in production. So what did we keep? What did we toss? And what did we need to invent, buy, or find? So what we had configuration management, kind of, with Chef 11. We had monitoring with Zabbix. Good. We had centralized logging on a single node that tend to fall over from time to time. And we added alerting in the last year and a half with PagerDuty. So this is great, but except for PagerDuty, this is basically the cutting edge of 2012 right here. And if you're keeping track, Chef 11 was in beta in 2012. So we basically needed everything. We needed better monitoring, we needed better logging, we needed infrastructure automation, we needed better configuration management, we needed auditing, and we needed code management. Because now we're looking at representing every single thing in our infrastructure as a piece of code. So we picked the list. You guys are probably familiar with almost everything up here. Git, GitLab, Jenkins, Terraform, maybe newer for some of you, and Packer. Inspec is probably the newest tool on there. Chef 12, and then we went to a full HA cluster for our logging, Sensu for monitoring, and we stuck with PagerDuty. So we kept one thing, so that's good, right? So what about the details? Every engineer is a developer, and every object in the infrastructure is code. Not every developer is a drunk, but I don't know, as one, I feel like I should be. And then the infrastructure was the really key point. You know, the infrastructure as code movement has really come up in the last 2 to 3 years, and that's been the thing. We're translating systems administration and operations guys to this DevOps, dev engineering role. That's the thing. They don't necessarily know that, so we had to get better integration, better insight into how to code. So how did we do it? We started with a new group in GitLab. So this is basically, if you've spent any time on GitHub, worked with GitLab itself, you can create a group that has specialized permissions and then grant everything to it. It's initialized with the basic configuration for any environment. Has Terraform files, has basic wrapper cookbooks for our clients based on the commonalities that we found earlier in this process. And then the entire environment is configured with the appropriate credentials, which is, for us, we're still trying to wrap our brain around because these are not all of them, but they are most of them. So we have clients in all of these, plus specialized bare metal areas. We have one running an AS300. Don't ask. So, I Briticized my English for you guys. We define our environment with Terraform. We create the infrastructure on the provider. Have you guys worked with Terraform at all? Has anybody? Hands? Good. You guys know what I'm talking about. This actually allows us to create a repeatable environment. We have a base infrastructure for everything that we do. It's laid out with our required monitoring nodes, our required proxies for access, our required ELK nodes, and Logstash proxies as well. So we create this on the infrastructure provider, and then we bootstrap it into Chef 12. So we have a basic environment, we've registered all the nodes, we have direct access, and then as soon as we do that, we want to run it through a set of inspect tests. So we know that our base environment is compliant with what our security standards have been set out to be. From there, then we actually layer on the other things that you would expect to get from any kind of configuration manager. So we add on the specific types of nodes. We might necessarily grow the environment based on client demands. We tie all of it into the appropriate monitoring and checks, and then log everything. So because we work in a cross environment where some of our private clients don't care, and other clients have specific auditory regulations that they need, we also can pipe that out elsewhere. This is our basic workflow. It's just got pictures because I like pictures. After the fact, we have all of our instances registered for periodic scanning with our security team, and we do quarterly red teaming, which is not common anywhere that I've encountered, but it's really important for us to understand where our environments are. And we do that because we've gone through this entire process before. We can clone a client environment in about 2 to 3 hours. So we can go through a client environment and have it red teamed the same day with no impact. That's the key part. From a security standpoint, all of our communications are locked down. We have HTTPS, where any kind of HTTP is required. If we need to set up a proxy to do that, we do so. SSH by default, all accounts are limited. Basic best practices. There's no password logins, keys only. That can be kind of a headache sometimes if somebody destroys their own machine. No root logins anywhere, ever, period. And ACLs are always defined to limit origin traffic to our sites and to the client sites. We commonly have requests to add like one-offs, which we generally do not do or push back long enough for them to give up on. We have a defined security policy, and that's kind of key because whenever we onboard clients, the clients are informed of what that security policy is. That's really important because a lot of them don't like having a security policy that they have to abide by. Client exceptions do come up. We will get to the point where it becomes a CEO to CEO conversation and they say, well, we absolutely have to have this dumb thing. Okay, we tell them that it's a dumb thing. Our security guys sign off on it, and the client has to take ownership, acknowledging that we told them they should not do that. And then internally, for our internal developers, no. Our security team is fully capable and empowered to tell people no, and we work with them hand in hand. So they are a partner, they're not, and an ally, and we don't even have to fight that battle. We say they want this, security team goes and does it, and then usually about 3 days later they came back and say, okay, done. So again, just to retouch on the minimum necessary access, devs have access to development environments directly, where they can change variables, where they can note system changes that need to be made. And there are no non-technical personnel in our environments. Business users really have no need to be on, adjusting something like I can't even think of memory parameter, something like that. When I came in, there were PMs that had direct access to almost all of our client environments. Not necessary. Infrastructure changes are all handled through Jenkins, through our own internal CI/CD, and code applications are deployed through either our internal dev teams or our client's CI tool. If they don't know how to use it, we help them do that. So everything else, we work off of base images that are built to a hardening standard that was approved by our security team. We have machines that are scanned for compliance along the build pipelines. The communications all secured, as mentioned earlier. Keys are encrypted with passwords stored separately, thanks to the talk earlier about using pass, because that's what we do. And then data objects for our configuration management are all encrypted. So for those of you familiar with Chef, you have data bags in there. We encrypt all of our data bags. When I'm usually talking out and about, just amongst friends and amongst peers, I get the why not X a lot. And there's a lot of different reasons for going through why we picked Chef, why we picked Sensu, why we picked whatever tool it was. But they had the best internal support. Our team knew Chef already, so taking that to the next level wasn't a hard move. It's the most compatible with the other parts of the organization, had the best trade-offs, and was the best overall needs for our organization. My caveat is always, you should find out what works for you and run it. I love Salt, I love Ansible, I'm iffy on Puppet, CF Engine. Some of our continuing problems tend to be a lack of client buy-in. They'll tell us no, just no. Yeah, it's a problem. We have to educate them, and that's one of the things that you guys can go out and do with your peers or clients or other departments, is just education is a lot of what's about there. One of the things that we do is we use small words and big references. So being from the States, we say things like Target, JPMC, Yahoo. People tend to recognize those as big issues, but they come back with, we don't have anything of value. And because we're working with marketing people, they seem to instantly forget that they use user data, and that's what people want. So translating that into something that they can understand is much less of a hassle than it seems to be in other locations. Developer demands. They tell us we're wrong all the time. Like, we don't know what we're doing, we haven't been doing it for 20 plus years. It's fine. I've been a developer. I was very much at odds with the systems administrators that I dealt with. Again, it's finding those people who want to learn and educating them, and then using them to educate their peers, so that you're not trying to create a communication block, you're trying to create a path. This is our biggest problem, and I think is one of the biggest problems in DevOps right now, which is the monitoring and alerting. And it's just noisy. We have requests that come in that do all sorts of things. But our biggest issue is client monitoring. So clients will ask us for specific monitors that go in and make sure that when things trigger, we get alerted and we can address them. Our latest response to that is to make sure that there is client buy-in. So if we get an alert, then somebody at the client gets an alert at the same time. So our pager duty, when it rings, the client knows it's ringing for us because it's ringing for them. It tends to cut down a lot on the client-driven noise. It still hasn't really helped out with our own internal noise, but you can't really do much about that except trim down your alerts and tune them. And then knowledge sharing. That's the biggest thing. We do lunch and learns, we do educational sessions, we do forums, we do anything that we can to get our security group involved with the rest of the organization, to make sure that we're involved with the rest of our organization. We invite our clients to come to these sessions so that they understand what we're doing to make sure that they're being treated like a first-class citizen all of the time. Because a lot of the issues that we deal with are, we don't feel like we're getting the thing that we're paying for. The future. Better education, more education. We can only do so much right now, so we're trying to do more. Reduction of noise by tuning our alerts, better compliance and inspection, and then just giving back, taking the things that we've learned and sending people from our organization to go and talk about it. So that's really all I've got for you guys, but I'd be glad to take any questions if you have any. All right, thanks.